In this video, I will be teaching you about the roots of quadratic equations. So whenever we have a quadratic equation or the graph of a quadratic equation, the roots of a quadratic equation are the points where that equation crosses the x-axis. So in this case, that would be over here and over here. And let's draw another graph. Let's say for this graph, the roots would be here and here. And you can imagine all the possible different scenarios for which we have roots of our quadratic equation. Now, one equation that's very important to keep in mind when dealing with quadratic equations, and especially with roots, is the equation that x is equal to negative b plus minus the square root of b squared minus 4ac divided by 2a. And it is this equation that gives us the roots. So this equation gives us the roots of the quadratic equation. So let's just say, for example, that we have the equation negative x squared. So negative x squared minus x plus 6, that's not a 6, plus 6, and we're asked to find the roots. Well, we can do that using this equation. Minus b is equal to 1 plus minus the square root of b squared minus 4ac, which is 1 minus 4 times negative 1 times 6, which is plus 24, divided by 2 times negative 1, which is negative 2. And this gives us the values of 1 plus minus the square root of 25 over negative 2, which is equal to, let's see, 1 plus 5 over negative 2, which is equal to negative 3, or 1 minus 5 over negative 2, which is equal to negative 4 over negative 2, which is 2. So our roots are at x is equal to 2, and x is equal to negative 3. So once again, the roots are simply the places where our equation or our graph would cross the x-axis. Now, when dealing with roots, there are three possible scenarios. So the first of which is that we have two distinct real roots. Now, in cases like this, what happens is our graph passes through the x-axis 2 times. So as you can see in these examples, our graph passes through the x-axis 2 times. Therefore, it has two distinct real roots. The second possibility is that it has two equal roots, or in other words, one root. So as you can see in both of these cases, our graph only crosses the x-axis at a single point, which means that there is only one root to our equation. Now, the last scenario is that there are no real roots. So with no real roots, our graph, such as this one right here or this one right here, never really cross the axis, so there are absolutely no real roots, as there is no point where our graph intersects with the x-axis. So that's simple enough. There are three different scenarios for how many roots we can have. You can either have 1, 2, or 0. Now you probably noticed what I wrote over here on the side, and we'll look into this. This is the reason why it's actually called roots. So it probably looks familiar from the equation minus b plus minus the square root of b squared minus 4ac over 2a. Let's, for a second, zoom in on this part of our equation. We have the square root of b squared minus 4ac. Well, one thing that we know about this, or one thing that we know about square roots in general, is that you can only take square roots of a positive number. So you can only take the square root of a positive number. Therefore, if b squared minus 4ac is positive, so if it's greater than 0, then we will have two real roots. Real roots. And that's because when we take the square root of this number, we will receive two answers. Now, when b squared minus 4ac is less than 0, then since we're not able to take the square root of a negative number, so we're not able to do this, this will give us no roots. So this will give us 0 roots, and therefore 0 answers to our equation. Now, when b squared minus 4ac is equal to 0, then what we're doing essentially is we're taking the square root of 0, which is equal to positive 0 or negative 0, which is the same thing as just saying it is equal to 0. And therefore, this value, or when b squared minus 4ac is equal to 0, gives us only one answer. Therefore, in this case, there is only one real root. So if we look back at our example up here, and we plug in b squared minus 4ac, so b squared minus 4ac, b is negative 1, so negative 1 squared minus 4 times a times c is 4 times negative 1 times 6, which is equal to 1 plus 24, which is equal to 25. Therefore, our value for b squared minus 4ac is greater than 0. And you know what this gives us? This gives us two distinct real roots. And when we solved for that, we got these two answers over here. So once again, when we're dealing with roots, or the roots of equations, which are essentially the points of intercept of that equation, so the points of intercept with the x-axis, there are three possible scenarios. Either we can have two distinct roots, so that means that our graph crosses the axis twice, and in that case b squared minus 4ac is greater than 0, therefore we can take the square root of it. The second possibility is that there are two equal roots, or only one root. In this case, our graph only crosses the axis once, so crosses the axis only once, and b squared minus 4ac is equal to 0, which essentially gives us only one answer. The last possibility is that there are no real roots. That means that our graph does not cross the axis at all, and that b squared minus 4ac is less than 0.